Hey guys, welcome back to another episode of the Weekly Coder. I'm Chris, and this week we are going to hopefully finish our Game of Life tutorial. And yeah, so let's hopefully finish that. Even if it runs over like 20-30 minutes, I may still try to wing it and finish it up. So be prepared. I think where we left off. Yep, we created random living cells. So, what we need to do is we need to think about the next step. So let's open up the game script and look at that for a second. First of all, we're placing all the cells. And then once we've placed all the cells, we want to get all the neighbors, right? So we're going to count neighbors. So that is going to be a thing that is going to live here. I'm just going to create void count neighbors. Alright, so again we're going to be in this loop. So for int y equals 0, y is less than screen height, and y plus plus. For int x equals 0, x is less than screen width, and x plus plus. Alright. So here we go with our famous for loop. So in this loop, what we're going to do is we're going to set a variable, and we're going to name it num neighbors. And that's going to hold a running count of how many neighbors we have around the cell. And if you guys have watched my Minesweeper tutorial, then this will look very, very familiar to you. Basically, we're going to check all the positions northeast, southwest, and then northeast, northwest, and southeast and southwest to see if there are any neighbors around this cell that are alive. Okay, so we'll do this. Say if, and we also have to make sure that we're not out of bounds. So we'll do y plus 1 is less than screen height, right? Because our array is 0 to 47 and 0 to 63. So if we're going to check the highest y, like let's say the highest y that we could be at would be 63, right? That's our y. So if we check to see if there's a square or a cell above us and we're already at the highest location, what'll happen is that if statement, it's going to say y plus 1. So let's say that we're at 64. Or sorry, we're at 63. And it's going to say, okay, well, is 64 less than the screen height? Because y plus 1, 63 plus 1 is 64. And if 64, obviously, is not less than screen height, which is 48, damn it. The screen height's 48. If we're at 47 and y plus 1 tests false, meaning y plus 1 equals 47, which is not less than the screen height, because that's 48, then we are just going to skip over that, because that's not even going to be a valid test. So we're not even going to do it. But if we are less than the screen height, which is 47 and below, then we are going to test. And we're going to say if grid xy plus 1 dot is alive. So if that's an alive cell, we are going to increment num neighbors. And just so, just so no one gets confused, this is north, also known as up. Next, we check east. So that would be x plus 1 is less than screen width. And if that's true, oh man, this is nuts. If that's true, Then we check if the cell in that grid location, oops, x plus 1, plus 1, y is alive. And if it is, we increment num neighbors. Same thing for south. So that's y minus 1 is greater than or equal to 0. Then we check if that cell is alive. So that's x, and y minus 1 is alive. Increment num neighbors. Then we're going to check west, which is going to be x minus 1 is greater than or equal to 0. If that's true, then is the cell at that location alive? So that's x minus 1y is alive. And then we say, yep, let's increment that. All right, we got the first 4 directionals. Now we need the next 4, which is going to be northeast. Oops. Let me go through and label these. So this is east, south, and west. Now we're going to do northeast, so that's if north, so it would be x east plus 1 is less than screen width, and y plus 1 is less than screen height. Then we're in the bounds. And then we check that location in the grid. When I say grid, x plus 1, y plus 1 is alive. Num neighbors plus plus. Oh, that was northeast. And we check northwest. So that's if x minus 1 is greater than or equal to 0, and y plus 1 is less than screen height. We're in bounds if that location in the grid. All right, so that's x minus 1, y plus 1. Then num neighbors plus plus. All right, 2 more to go. So it'll be southeast. That's if x plus 1 is less than screen width, and y minus 1 is greater than or equal to 0. We're in bounds, so then if grid x plus 1, y minus 1 dot is alive, that would be num neighbors incremented. Finally, we have southwest. If x minus 1 is greater than or equal to 0, and y minus 1 is greater than or equal to 0, we're in bounds. So check the cell in that grid. That's x minus 1, y minus 1 dot is alive. Then num neighbors plus plus. And then finally we say if num neighbors is greater than 0, we're going to basically tell it that the what the num neighbor, actually, you know what? No, we just need to tell it what the num neighbors is. So grid xy num neighbors equals num neighbors. So this will tell us how many neighbors each one of our cells actually has. What is happening here? So this gets called on update count neighbors. So then this is going to run. First of all, this is going to run. And then it's going to count all the neighbors. And nothing's changing, so all the neighbors should literally stay the same throughout the running process. So we could actually look at see what that looks like. If we run this now, so there's a loop running here. You can't see it, but if we look at the scene view and we click on one of these cells, we can see that the num neighbors of that cell is 3. And then as we scroll through these, see like this one has 5. And it's not an alive cell. This one has 3, 2, 1. So they all have neighbors. All of that has been counted appropriately. So we're good. The next thing we need to do is, well, let's call it population control, right? Because that's basically what we're doing here. The game of life. Population control. So, again, we're going to do this loop for int y equals 0. Y is less than screen height. Y plus plus. For int x equals 0, x is less than screen width, x plus plus. Alright, so that's our loop. So now what we need to do is we need to go through and we need to basically apply our logic, right? So let's write this down. These are the rules, okay? Rules. Any live cell with 2 or 3 live neighbors survives. Any dead cell with 3 live neighbors becomes a live cell. And then all other live cells die in the next generation. And all other dead cells stay dead. So, how do we do that? Well, first, let's see. If grid, the only ones we're going to change, well, we're going to change them both. So first, let's see if we're working with a cell that's live, right? Otherwise, the cell is dead, right? Cell is alive. Cell is dead. So if we're working with a cell that's alive, right? It says here, any live cell with 2 or 3 live neighbors survives. Okay? So that means that if it doesn't have 2 or 3 neighbors, then it's going to die. That's what we want. We want it to be dead because this then happens. All other live cells die. All other live cells that don't have 2 or 3 not live neighbors, they die. Okay, so the way that we're going to write this is very simple. Is if grid xy, I'm going to check how many neighbors, right? If that doesn't equal 2, what am I doing here? If the number of neighbors doesn't equal 2, and the number of neighbors doesn't equal 3, then we're going to kill the cell. And we're just going to pass in false to our method here. Okay? Now, if the cell is dead, right? Any dead cell with 3 live neighbors becomes a live cell. So, if our cell is dead, we simply go in here and say if grid xy dot num neighbors, right? If we have exactly 3 neighbors, then we want to bring the cell to life. Set alive true. Okay. So now we've got this method, population control, that we need to call after we count the neighbors. So we count neighbors, and then we call population control. So we find out how many neighbors each cell has, and then we control the population based on that number. So if we save this and run this now, remember there's one little trick that we still have to implement. Remember, Unity runs at 60 frames per second on a good day. So this is actually an interesting pattern. Seems off in a way. Now, something definitely seems off. This does not seem right. So what are we doing? Screen height, screen width, screen height, screen width, screen height, screen width. Let's just go over this really quickly. So we're saying y plus 1 is less than screen height. X, y plus 1 is alive. Num neighbors. X plus 1, screen width, which is east. X plus 1, y. We've got y minus 1 is greater than 0, is south. X, y minus 1 is alive. Num neighbors. West, x minus 1 is greater than or equal to 0. Good. X minus 1y is alive. Num neighbors plus plus. X plus 1 is less than screen width. And y plus 1 is less than screen height. Grid, x plus 1, y plus 1 is alive. Northwest, x minus 1 is greater than or equal to 0. Y plus 1 less than screen height. Grid, x minus 1, y plus 1 is alive. Yeah. Oh. I'm checking if it's alive. It's interesting that that would make that happen. It's just saying if it is. Like if it has something, then the number of neighbors will increment. That was probably the whole issue. But let's just go through and make sure the other ones are okay. X plus 1 less than screen width. And y minus 1 is greater than or equal to 0. X plus 1, y minus 1 is alive. And x minus 1 is greater than or equal to 0. Y minus 1 is greater than or equal to 0. That's southwest, that's the bottom left corner. X minus 1, y minus 1 is alive. Neighbors increment. Save that and go back to Unity. Oh, that actually looks better. That looks more believable. Yeah, this actually looks pretty good. Okay. 60 frames a second. Well, that's pretty cool. What if we want to slow that down a little bit? So there's a very simple trick to do that, and we'll just implement a timer, right? So let's do this. Let's add in public. Let's call this speed, and actually we need to tell it what it is. Public float speed equals. Let's set that to let's do 0.1 F. Let's try that. And then the only other thing we need is speed timer. Let's do a timer. Let's just private and private float timer equals 0, and then here in the update method we are going to say if timer is greater than or equal to speed, then we want to run the stuff that's in the update method. Actually, we also want to reset timer back to 0, and then we run this. Right? 0 F. Otherwise, we want to increment timer by time.delta time. Right? So very simple. We're defining a speed variable. We're setting its value to 0.1f. And then we've got a timer variable that's going to start at 0. It's going to, at each iteration, check the update loop. It's going to check and say, hey, is timer greater than or equal to speed? And at first it's 0, right? And if it's not, then it's going to be incremented by time.delta time, which is the amount of time that has passed since the last frame. And that should do it. So if we go into Unity now, press play, you can see that it's definitely slowed down quite a bit. So we can see more of how these patterns kind of form. So we can slow that down as much as we want. And we can speed it up as much as we want. So if we run it at, you know, well, I think 0.1 looks pretty cool. You know, and because the initial, like, let's see where we're at, 22 minutes, very good. So because of the initial, like, pattern that we generate as random, it gives us a different kind of look each time of the patterns that get generated. Now I've seen some pretty cool things online where people have come up with all kinds of generated patterns that would then, you know, kind of play out in a different way. And I guess if you wanted to somehow keep like the patterns, like if you wanted, like if you liked the way a specific pattern played out, what you could do is you could save out the grid array into a variable and store that somehow in a, yeah, you could store that in a file. You could basically write out the game object, the cell game object. You could write that out to a file, and then you could load that up again. So you could actually make like pattern files for Conway's Game of Life to run in Unity, and then at the start of each whatever, you know, pattern generator, you could basically, instead of creating random patterns, you could open, like from your file, you could basically say, hey, load this simulation instead. So now we see we have some stable patterns and some oscillating patterns. It's pretty cool. It's like, you know, it's different every time. All right, and some of these are just like awesome. Some of these are very, very cool. Some of them last longer. Look, we just had like almost like a heart down here. See how quickly they like just multiply and like move along. So awesome. So anyways, you know, the other kind of thing that I was thinking about playing with is adding some other sprites that kind of maybe identify how many neighbors each has. So as it goes through and changes the amount of neighbors, the colors maybe would change, right? Like let's say if you know, if it has 3 neighbors, it's red. If it's got 4 neighbors, it's blue. You know, whatever. So that way you also get some colors, and I guess it kind of starts to look maybe like a kaleidoscope. Anyway, so yeah, it's pretty cool, pretty mesmerizing to just look at and see what develops. This is your program; it's running, and you know, it's kind of cool, very very cool. Yeah, this is awesome. So I'm gonna have to stop looking at this because I could literally do it all day. Anyways, so hopefully you guys enjoyed this. As kind of a little bit of a break from the usual game tutorials that we create, and let me know if you guys are interested in writing some sort of file export import utility that would allow you to save out specific patterns that you may have liked. Um, you know, I might do that just for my own amusement, just to see what because I don't think I've ever done that before. I've used user preferences to save objects out, and maybe yeah, but I don't think I've ever written like specifically to a file. So it's something worth looking into, and I'd be into it if you guys wanted to see it or not. Let me know if you guys enjoyed the episode. Give me a thumbs up. Let me know in the comments, questions, whatever. Don't forget to subscribe. Tell all your friends. Don't forget to visit me over on Patreon to download the entirety of this project, source code and everything. And, just if you want to show some support for the work that I do here, that'd be great. Otherwise, I will see you guys next week.